Hello, and welcome to another episode of Fun Times and Statistics, an example edition, where today we're going to talk about how to do some two-mean testing. So, the file I'm using in Microsoft Word to have the written versions of these questions that we're going to go through can be found just below this video. Or is it just above? It's either above or below the video. I forget how this attaches. Anyway, we're going to go ahead and do through number one, and depending how long it is, I might include number two. If not, it will appear in a second video. So let's look at resting pulse rates and the relationship between smokers and non-smokers. So the resting pulse rates for a random sample of 26 smokers has a mean of 80 beats per minute and a standard deviation of 5 beats per minute. Among 32 random non-smokers, the mean and standard deviation were 74 and 6 beats per minute. Both data were roughly symmetric and had no outliers. Is this evidence that there is a significant difference in mean pulse rate between smokers and non-smokers? How big? Okay, couple things. I'm going to lay out our plan first of what we're going to get up to with this. So I'm going to lay out my steps that I need. So I need to do the hypotheses first. And then I'm going to need to come up with my model and see whether or not it's reasonable. So I'm checking my requirements. And then I'm going to do the mechanical part. So that's going to be where that Minitab screen is going to be coming in. And then we're going to do conclusion. And normally this is where we would end if we're just doing a hypothesis test. But then there's this additional part where they're like, how big? So I got to have some follow-up. And that follow-up is going to be me estimating what the actual difference is. And for that, I'm going to be using a confidence interval. Okay. So first up, we have the hypotheses. We suspect that the mean, let's do insert symbol, mean for smokers, which I'm just going to use as an S. Come on. Let's see, what am I trying to think? Is it different? Oh, okay. I'm just looking for, is there a difference? So I don't know if it's greater than or less than or anything like that. So I'm going to say that the difference between smokers and the average mean for non-smokers is 0. So that's my null hypothesis. I should probably label it so that it's clear what I'm up to, but the fact that it's an equality is kind of a clue that it's the null and not the other one, you know what I'm saying. Anyway, and so then my alternative is going to be that it is different. So since I'm looking for is there a difference or not, this is going to be a not equal to. Because there's no statement about greater or less than. I'm just looking, are these two different? Okay, let's check the model and whether or not it's reasonable. So we're told that the samples are random, so that's good. So we have randomness. Sample is random. And I believe that smoking is independent, whether or not a smoker versus non-smoker is independent, whether or not you have another smoker versus non-smoker. So, and independent. 26 people that smoke and 32 people that smoke is probably not more than 10% of the entire population of both those groups. So I know we meet the 10% condition. So less than 10% of the population. What's up next? Then I need to see if it's normal looking. So they tell you that it's roughly symmetric and has no outliers, and that's enough for you to get nearly normal. You've got at least one of the characteristics of the normal distribution. So I would say both the groups are nearly normal, so we're good to go. So we are greenlit to do a 2-sample T. Woohoo! And this is going to be an unpooled one. And the reason that this is going to be unpooled is because I'm not making the assumption that their standard deviations are the same at all. Let's get into the mechanics. And for that, I'm going to pull up Minitab. So to do this in Minitab, you're going to go to Stat, Basic Statistics. And this is our first time doing this, so of course it's being buggy. And there's two sample tests for doing means. Notice all the mean tests are separated from all the proportion tests. And there's the two sample t and the paired t. We are doing the two sample because this is not a paired. It's not a paired because you don't have individuals measured more than once. It's not the same individual measured when they're a smoker and when they're a non-smoker. It's two different groups of people. So we'll click on this. And up she comes. And the first option that Minitab always wants to choose is oh, you have data. But I don't have data. I have summary statistics. So I need to change this to summary statistics. Summary data. All right. So I'm going to do the, let's see, I did the smokers first in my hypotheses, so I'm going to make the smokers first in my data as well. So 26, sample mean of 80, and then where's my standard deviation? 5. My other one is 32, 74, and then 6. All right, so I'm going to hit options because I always hit options to check to make sure everything's set up correctly. So 95%, that doesn't really matter. I'm not doing a confidence interval. Hypothesize different is 0. I'm thinking it's different from 0. It's a not equal to. And then notice there's this box down below that says assume equal variances. That's what you would want to check if you were pooling this. We are not pooling, so this is exact setup we want. Go ahead and OK. And then hit OK again. And then it's going to produce a bunch of stuff for us. Okay, so the first thing worth noting is that, where is it? Oh, there's our p-value. It's super tiny. Okay, so I'm just going to copy my mechanics from Minitab. All right, so I'm just going to copy this over to my mechanical section. If I was doing this by hand, I would clearly do this by hand, and so that's what would be found here. All right, so let's get into our conclusion. Well, my p-value is small. With a p-value of 0.000, aka super tiny, it's unlikely that the difference in the samples is caused by just sampling error. That the difference in the samples is caused by sampling error. So we are rejecting the null hypothesis. All right, so that's great. That was the decision I made. Let's actually write the rejection. The evidence suggests that the difference, that there is a difference in the average pulse. Do I want to use the units here? Oh, resting pulse. I should include that. Resting pulse rates for smokers and non-smokers. And then I'm just going to throw my super tiny alpha at the end. At the 1% level, which, I'm going to use P. With a p-value of like 0.000. Okay, so I know what you're thinking. Why don't I just write 0%? Because there's a difference between 0.0000 and 0%. 0% is that I have nothing but zeros present. This being like this means that I could have something like in this next decimal place, like a 3, and then this would get rounded to 0.000 if you were dealing with 3 decimal places. So the point of this being is there may be something there, it's just super tiny. So we report all the places rather than just writing 0%. Okay. A little bit of follow-up. We're going to look at the 95% confidence interval. So I'm looking specifically at this part right here. And then I'm going to use that to draw some conclusions about what the actual difference is. So since this is always positive, we know that the first value is actually larger. And by how much? About this much. So we are 95% confident that the average resting pulse rate for a smoker is between, let's see, 3.11 and 8.89 beats per minute, higher than the average pulse rate for a non-smoker. Oh, and I should throw resting in there. I forgot to write resting. And I'm also having a hard time spelling smoker. Guess I can't be a smoker. I'm not cool enough. Oh, I have resting on there. I just forgot to put it here. So not only are you saying specifically what the difference is, but by how much. Yeah. Okay. So I am going to check to see how long this video is, and if it's too long, this is goodbye, and look forward to part 2.